Welcome to the video lecture. So in this lecture I am explain about brake test on DC shunt motor. Generally motor it converts electrical power to mechanical power. So if any machine motor you want to find out the efficiency, first of all you find out the output and input. So the main aim of this test is to determine the efficiency of a given DC shunt motor. So this is the circuit diagram for the DC shunt motor. Normally motors are coupled to the mechanical load through belt drives or some thread. So in our laboratory we are providing this motor is coupled to a brake drum. The drum is provided to the two spring balances and with some fixed point. So we have to tighten them automatically. Overburden is provided to the output side. So then based on that, according to law of conservation of energy, the output is provided automatically, the power is drawn from the input side. The question is how to calculate input and output. So motor input is electrical power and output is mechanical power. So that's why here the how to calculate electrical power. So we provided the one voltmeter and one ammeter, voltmeter and ammeter. So here this ammeter measures the line current and it measures the how much voltage applied. Based on the nameplate details, you provide the rated voltage, and once you change the load with by varying this spring, tighten the thread, automatically it draws the current. So different load conditions we can calculate the both input and output. So how to calculate the input? The input power is power of it is electrical power. So we calculate terminal voltage and load current. And output power, mechanical power. So it have a we are measured with output power in the mechanical power. The formula for mechanical power, torque into angular speed. Torque into angular speed. Here omega is nothing but, so in terms of RPM you can write it like this, 2 pi n by 60, where n is the revolutions per minute. So it is the radians per seconds. We can take the angular speed. So we are providing this, we are getting this 2 into 2 pi n by 60. Probability is the values 2 pi n t by 16. This is the output power formula, this is the input power formula. So it is a direct load test. We have provided the load and different loads we have to observe the what is the speed, but how to calculate the torque. Generally the torque is nothing but torque is equal to force into radius. So we observed here the circuit diagram. Yes, the twisting force occur here once the machine is running twisting force. The tangential force into radius is given to the torque. So here but F is equal to here, generally we know that formula, F is equal to, we write it the two ways, the mass into acceleration, but here we can take the mass into gravitational force mg. So mg into r, in practical way we take the radius of the pulley, and also sometimes we can maybe the thickness of the, for accuracy we can consider the thickness of the belt also we are taken in terms of meters. So thickness by 2 and we are adding in one side, so per clarity. So this is the formula force, and once you calculated this, F is equal to mg into r plus t by 2 into mg r is nothing but the torque formula. So mg is nothing but force, sorry this is called as the torque. Torque is nothing but mg into radius of the pulley. So here we apply the, here F is equal to ma, another case we can take it the fixed value mass into g, mg into r plus t by 2, r plus t by 2. mg into r is nothing but general formula, but you are considering the brake drum, we are added the thickness of the belt also, we are considered for better accuracy, and this is the Newton meters. But how to mass is how to calculated here. It is the difference between the in the circuit diagram. Here are the two meters are there, here kg meters. We are measuring the how much pressure it is available in both side, and based on that we can difference of these two is called as a total mass of the LU. So here S1 difference of S2 into G is nothing but 9.81 into R plus T by 2. So this is the we are giving the total torque of the how much torque is developed in the motor. So this is the torque. Once you know the torque formula, we can substitute here, we get the output. So this is the input is nothing but the electrical power Vi, output is nothing but angular speed into torque, and the torque is calculated like that in the experiment. But different conditions, just you have to for better formulas used here to find out the efficiency. Shaft torque is equal to 9.81 S1 difference of S2 into R. Here R is nothing but R plus T by 2 here. Here S1 and S2 is nothing but the reading of spring balances, and R is the radius of the pulley, and is the, I told already, speed in RPM. Output power is equal to 2 pi Nt by 60. Our shaft torque we are considering the output, and input power is the Vi. So total in the P is not so overall efficiency is equal to output power by input power. It is a simple experiment. Generally this experiment is used in the below 5 HP motors. Why? Because the big machines normally indirect methods are used, that is the another method. But here in the brake test, this is the way to calculate it. As per circuit diagram, first connect the circuit, and once initially we are provided the rated voltage. Once the voltage, note down the no load current and no load speed. Initially the S1 and S2 is 0. Based on that, remaining torque and output power and input power calculated as per their formulas, and finally efficiency is nothing but output by input. So once you after that we have to apply some load by tightening the belt, and based on that it draws the current is increased. Once the current is increased, you observe that how the speed is varied, how the torque is produced, what is the output and also input, and ultimately where it is given to the efficiency is more, we are observed in this here in this circle. Once you note down all these values, finally we draw their characteristics. So output versus speed with respect to output. Once the output is increased, the load is increased, how the speed is varied. Generally in the DC shunt motor, a little speed is decreased because the load is increased, automatically IRA drop is increased, because of that speed is reduced, and also load current is increased, how the efficiency is varied. Generally we are observed at the 3/4 load, it gives the maximum efficiency. So this is the observations we are calculated, and also based on these characteristics, whether it is the good or bad, or otherwise it is a good performance or bad performance, easily we are identified. Thank you.